Welcome to the Digital Forester Podcast, where we speak to forestry leaders and innovators who are shaping the future of forestry. Hey, everybody, welcome to the Digital Forester Podcast. Today I'm joined by Howard Butler. He's the president of Hobu Inc. Howard, how are you doing today?
Great. Good to hang out with you and have a good chat.
Yeah, for sure, absolutely. So the question I always at the start that I ask folks are, where am I reaching you today?
We're located in Iowa City, Iowa, although we have a few of our developers spread around the country.
Yeah, absolutely. So when I was doing some research on you and Hobu Inc., I was thinking I've been at this for many years. Then I looked at your profile on LinkedIn and I was like, I think Howard might got me. He might got me on this one in terms of like the years at this. So maybe to start things off, maybe introduce yourself, your own background. I don't believe it was in point clouds and computer science, maybe an agriculture theme there. But why don't you introduce to our listeners yourself and how you got to be where you are today?
Yeah, I tell people when I went to school, I studied dirt. I was actually went to Iowa State and studied agriculture. And as part of my master's program there, I ended up doing a bunch of software development to help with my research. And so ended up doing GIS things like, typical sort of vector overlay analysis type stuff and really enjoyed it and I found I was pretty good at it, especially kind of the development side of it, scripting with ArcView. At that time, it would have been ArcView 3. And so I was doing lots of ArcView and so then I got done with school, and I couldn't really find the gig I was looking for in the agriculture space. And had a contact who said, "Well, we're always looking for GIS programmer types at the university." And so Iowa State, I found a job there with the National Resources Inventory. And so it's a program that has gone on since the Dust Bowl era, so the 1930s. And what they do is they have about 70,000 sample frames that they fly with aerial photography at a repeat cadence, and they look at land use and land change in the landscape, and they've been doing that for 60 plus years. And so when I started on with them, everything was Mylar, film, light
You
tables,
might have to explain what
manometers.
Mylar is, by the way, for some of our listeners.
It's this plastic sheet that they would put on a projector and take a look at it and potentially draw on it and measure with instruments. And so we started taking that and digitizing that process. And so doing software engineering to take that from a manual sort of sampling and measurement to doing it in heads up digitizing and capturing that data and sending it into the survey. And so I started developing lots of software tooling to make that work and found that I ended up doing a lot of open source software development and needed a lot of open source software tools to pull that off. And so through that job, I started doing a lot more open source software development, both as a user. At the time, open source software was just kind of coming over the horizon for certain groups of folks, and so I became very active in the open source community. And my wife and I moved across the state of Iowa from at the time we were in Ames. We moved to Iowa City. She took a job over here, and so I decided at that point, well, maybe I can just do this open source GIS thing for a while. And so what was kind of a moonlighting consulting business, then we took into turning into a full-time business.
Yeah, yeah, and I think I think 21 years now, so we'll dig into Hobu Inc. a little bit more. But I'm curious to know. So myself, I went. My undergrad was at the University of Guelph in Canada, and we joked it was MUU. It was very much agriculture and dirt, so I can relate to that. Um, but I'm curious to know how, in your journey, was it just where you grew up, agriculture was that logical progression for studies, or was there an event in your younger life that got you thinking about dirt and being
Oh,
interested?
I grew up on a corn and soybean farm, and so in southern Minnesota, and so we were just, uh, my dad had gone to university, and he's like, "Well, you're going to go to university before you come back here and do any of this," and so working on the farm, working with the landscape. I That's also where you kind of get the appreciation for mapping and being able to kind of chart out what's going on in the landscape because it's not all the same. And you spend your time driving a tractor over and over and over the land. You quickly notice, well, it's not all the same, and you're not doing the same thing in all the same in across the entire fields that you farm. And so when I went to school, then precision agriculture was just starting to become available, but the capital cost of doing it was very expensive. And so, I wanted to do that more on the technology side. And as I so that my program was at least in school was to do more of that kind of thing. But then I kind of veered into software engineering land and have been there ever since.
Yeah, yeah. So before our listeners go, am I on the right podcast? Is it am I listening to the Digital Agriculturalist or is this the Digital Forester podcast? We will connect the dots. Howard and I will connect the dots on the very cool things he's been working on the point cloud space. So bear with us as we go through some of the background. So one thing I found is that if we substitute precision forestry people in their younger careers with, or sorry, precision agriculture with precision forestry people, there is a there seems to be a commonality with people there where switching to software was not as hard or maybe as a big hill to climb. Was that the case for you? And if it was that mom's side that brought the genetics of software engineering because dad was working the farm? But where did that come from? And was it an easy transition that just kind of clicked and you found software and you're like, hey, this is really cool. I get it. I can run with it. Was it a hard thing to go to that software route or was it easy for you?
No, probably not. I mean, I had a computer growing up, and I was kind of messing around with stuff anyway. I always enjoyed on the farm. There's all these kind of jobs that you have to do. You have to be passively good at lots of things, we'll say. And so the working in the shop and fixing things was always very interesting to me, but I was never very good at it. I was much better at the figuring out the rates that we're going to spray or figuring out how to plant this and that and kind of working with the equipment that way, but not so much like welding and kind of engineering and mechanical type stuff. I was not so good at that. I could kind of wire things together with electrical as well. So, I mean, those kind of skills were certainly quite valuable on the software engineering programming side as well, because that's essentially what you're doing when you're doing software engineering is you're either building systems or wiring systems together.
Yeah, yeah, absolutely. So obviously being the president of Hobu, I believe it's last time I checked, team of six software engineering engineers working on different open source things. Um, why don't we tackle, I won't say it's the elephant in the room, but I suspect some of our listeners are hearing the open source thing versus, and I know you've been asked this question probably 1 billion times, but the whole open source versus closed source. Where do you stand on that as president of Hobu Inc? What's your vision for the future, maybe of open? We'll leave it as open versus open data, open source software. But you mentioned you had to embrace a lot of open source things in the early days, which naming ArcView 3X right away. Back then, we also had grass. We had other things at play. So again, I'm dating myself or we're dating ourselves. But maybe share with us your thinking on open. What does it mean for you? Why did you start a company going on now 2 decades, well, over 2 decades now, focused on open source and what was the motivation, thesis, driver, what gets you up every day?
I mean, ultimately, it's like best tool for the job, right? And so, being able to find the best tool for the job is an important part of the challenge. And so, when you're in the open source space, you have too much choice, right? There's just so many options and so many possibilities for taking these systems and wiring them and building them together. Another sort of good thing about at least open source software is it's technology you own, right? It's communally a software that's available for everyone, but when you take and build a system with open source software, you own that system. That's both good and bad, right? So the good side of that is nobody can take it away from you or cause you to license it or get sold and cause you to have to change your business model. But the downside is you own that technology and technology, especially software technology over time, rots essentially, right? Like the facts or the situation which caused it to work at one point in time, they're not always true as time goes on. And so you need to maintain or find support for that software as things go forward. And so, our business model, certainly with the open source software, is finding technology niches that we can provide capability, but it's not necessarily capability that is differentiating, right? So open source software does really well at kind of low level things where everybody needs it. Not everybody wants to pay to have it be built, and everybody would like to share in it being communally maintained. And so that provided the opportunity for us. And so our sort of role is either being shepherds or the phrase I've Paul Ramsey from Post GIS, another Canadian GIS person,
Yeah.
the beekeeper model, right? Where you have this open source software package. Not everybody wants to dive in and participate as a contributor to those projects, but they want to be able to find somebody who can help them do that. And our company provides that kind of role for projects that we're either active in or we lead, like the Poodle project, Point Data Abstraction Library, which is how we get to lidar here.
Yes, yes, absolutely. So very cool. So maybe thinking about from when you started Hobu Inc. and the journey of open source, maybe walk us through some of because I guarantee there's some listeners that are probably going like they're going to get to the forestry stuff, the point cloud stuff eventually, but I don't think maybe they appreciate how much open source, especially if they're on the geospatial GIS side of things, that they may have touched in their journey or their career today. Because I know looking at your website, it took me back down memory lane. I think you had PROJ as an item there, and I remember writing code against Proj 4 and doing all this stuff. But maybe walk us through from maybe memory lane in terms of some of those seminal, if you will, open source projects that you've been fortunate to be able to participate with to bring us maybe up to the point where we start talking about some of the more advanced point cloud, albeit, where how it's generated by lidar or whatever. It's a point cloud library. But maybe walk us through memory lane in terms of some of those cool, maybe milestone or watershed moments around some of these open source technologies that you've touched.
Yeah, so early in my career when I was doing that land survey stuff, GDAL, I think, was like 4 or 5 years old at that point. Proj had been available since 1983, although it was kind of just a tarball of software that people kind of packaged and used themselves. It wasn't really a software project. And the way these projects started communicating was via email lists, and that was the community started to come together. And I was very active in both as a user, kind of bootstrapping myself, and then eventually as a developer. So the GDAL project, I've been very active in for at least the last 20 years. GDAL depends on Proj. So Proj is a very important capability for dealing with coordinate systems. Ultimately, that's what makes geospatial geo, is where it's located. And so in the end, Proj is underneath most soft. You have a coordinate system engine under almost every geospatial software, right? And so those are two projects that I've been quite active in leading initiatives to do things like, well, lately with the GDAL project, it's the GDAL sponsorship program, which large commercial entities provide financial support, and that maintains that those resources provide capability for things in the software project that would not have a natural sponsor, like continuous integration and testing, or any sort of security type things, or in recent activity is updating the command line interface, the GDAL. And so yeah, so been very active in those. And then as we started moving into the point cloud space in 2008, nine, something like that, it was taking those base capabilities and adding that sort of geospatial spin to point cloud data. So most of the point cloud software libraries that were available at the time when we started Poodle were uh, very close to the center. Here's your point cloud data. It's up to you to go connect that data geospatially to something to do geospatial type things with it. And so, the niche we saw was, we had this experience with GDAL, which is, raster and vector processing pipelines and algorithms for for and format translation, but there wasn't that equivalent thing in point cloud space, especially with that geospatial sort of flavor. And so that's how we get to developing the Poodle project.
Yeah, very, very cool. So, so how we came to be connected, I was talking to Jason. Well, I wasn't talking to, we were messaging on LinkedIn. I was messaging Jason Stoker at USGS, and he said, you should talk to Howard on some of the point cloud stuff. So thinking of that, lots of commercial off-the-shelf software have point cloud libraries and visualization capabilities. And I've played with some of the ones you've talked about, and they're really, really impressive. So, first question is maybe with those libraries, was this a commercial entity or some entity out there that was contributing to the open source movement and saying, hey, Howard, it's like we've got some funds that we've secured from people. Can we accelerate the roadmap on some of these libraries? Or was this really one where you're like, just to your point, hey, GDAL was pretty mature with the raster side. I want to do something on the point cloud side. Was there someone who was providing a little bit of a jet fuel to get
Uh,
going?
yes, that jet fuel absolutely came from the U.S. Army Corps of Engineers, Cold Regions Research and Engineering Laboratory. They're located in Hanover, New Hampshire. And so in 2008 and 9, they reached out to us and they're like, hey, we've been pointing LIDARs at glaciers and modeling their movement and change and so on. And we need some way to make a database of all of this stuff so we can use it for our research. And the software tools that they needed were deficient. And they also had experience with GDAL. So they're like, well, we kind of want a GDAL for point cloud data. I mean, one doesn't really exist, and you're active in GDAL, so maybe you can help us pull that off. I had done some point cloud processing. Iowa was actually one of the first states to do a statewide capture in 2007, 8, and 9, something like that. And so they had a little bit of funding to help with some tooling. And so I worked with Martin Eisenberg and did some LAS tools stuff at that point for them. And so I had a little bit of experience with it, but I also had this kind of background in GDAL and the geospatial libraries. And so I was able to put this together. But CREL, or Cold Regions Research and Engineering Laboratory, certainly has been the group that has provided the resources and to allow us to develop Poodle to the point it is today. I mean, we have plenty of other contributors as well, both in kind as software engineers and financial support to our team as well. But CREL was definitely the driver of a lot of that.
Right, right. And I assume making these software libraries that a lot of us probably take for granted takes time. So how long did it take to get this from concept to maybe it's never finished because I was about to say the finished product, but it's evergreening, ever growing. But in terms of getting started to when you can actually say, this is adding value for our funders, our sponsors and whatnot, maybe walk me through that period of time. Was it 3 months? Because the
Oh no,
Hobu
it
tune's
was more
quick, or
like
was it longer?
no, it was more like 3 years, 4 years before it
Wow.
was like
Okay.
I mean, the initial releases were like it did what it said on the box, but it had like sharp, stabby bits, and it was really harsh on the user. And so like your first implementation of software, even once you get it to work, is just you learn so much about what you learn so much about what the problem is you're actually trying to solve by making an attempt at solving it. And so that those first couple releases of the software were really quite harsh, because we were learning, well, what concepts do we need to implement? We needed some kind of a data model. We needed some way to have it speak geospatial. You need some way to organize those point clouds in some kind of index structure that works well for different kinds of query patterns. And then ultimately with Poodle, of course, the one of the more important things has been the concept of a processing pipeline. Right? We have a bunch of actions that happen to the point cloud data in usually a sequential set of operations, and being able to model and construct that once we got that kind of wired together, and I was 3 or 4 years into it, then it became clear like it was useful. It was actually um, convenient enough to use. It did what it said it did, and we could make it perform well enough that it was worth bothering with. That's also a big challenge. Is I mean, with point cloud data, you're dealing with so much content that these algorithms and tools have to perform, or otherwise you're just, they're very frustrating or very expensive to work with.
Right, right. So maybe for our listeners, walk us through a use case of how they might use Poodle because let's say I've the state of Iowa, you said we're one of the first to fly wall-to-wall lidar. So what would they do? They would do this library to kind of push through a bunch of LAS files through and it would index, put it in a database, or maybe walk through that flow of what somebody could do when you say about pipeline so that they can understand and maybe connect the dots on how maybe in the future they could actually use Poodle to do some things that they're maybe doing
So,
in a more archaic way.
like the super common scenario is most people hate point clouds and they want a raster, right? So, but they want a raster kind of cooked to their specification. So, for example, give me a raster, a surface model that gets rid of all the points that aren't labeled ground, for example. That's like, the most common thing. And so reading so the first stage in that pipeline would be reading those points. An intermediate stage is filtering out the stuff that isn't ground and then interpolating it to some specification, right? So those kind of three steps of a pipeline. Um, a- Another sort of twist would be, oh, we want to clip out the water bodies and we want to either filter them or flatten them to some elevation. Or maybe we want to actually take the point cloud and attempt to assign our own ground classifications to it because we don't either like what was provided by the data collector, or maybe we have a better algorithm or approach that we can use to come up with that ourselves. And so being able to sequence those operations together without having to write out a new data set every time is very important to making it perform well, right? So in a lot of cases, you'll have operations that in Poodle, we call them streaming, where it means we can just read point at a time and kind of pull those points through. Other times we have data that are not streamable, or we have to read them all at once. And so in that case, we need to come up with a way to break the data apart into small enough chunks that we can read them all at once. And so that requires using some sort of indexing scheme with the data, either a quad tree or an oct tree. That's typically what we would use that allow us to take that and divide it and conquer, because that's ultimately the the only hammer you have with point cloud data.
Yeah, yeah, absolutely. So by saying that, would it be a safe assumption to say you need a pretty heavy rig or workstation computer with lots of RAM, RAM still king to run these things? The more RAM you got,
No, in fact, we've been trying to push things the other way. So, if the data are well organized, and so we have a couple of technologies that we've developed that do this. So, one is called Entwine point tile, which is essentially store all of these, like the state of Iowa, or in our case, we manage the AWS public data set for the USGS, and that's all 70 plus trillion points for the US. Those data are organized in a cloud structure that you can your software can interrogate and say, "Hey, I only want to read data for this small patch, and and for this small patch, I only want to read the data to a specific resolution," right? And so, being able to control, I call it the byte size of your algorithm, is super important so that you don't have to have a system with gobs and gobs of RAM and lots of CPUs. I mean, those are always great because you can eat bigger bites, but your software tools need to be able to control their bite size, because sometimes the computational complexity of your algorithms either is just kind of degenerate, and especially as your data gets larger, it gets more and more degenerate, and so you need to be able to shrink that down. And so inclined point tile is the one technology, which is kind of I'm in the cloud and I can just spray a bunch of data into a cloud object store. And then the other technology we developed is something called cloud optimized point cloud. And so cloud optimized point cloud comes from the need that we have these LAS or LAZ files kind of floating around. LAZ is it's the shapefile of point clouds, I think is an accurate way to say it, or maybe the geotiff of point cloud. I mean, it is a level two format that's used for transmit and archive of geospatial lidar point cloud. And what COPSI does, or Cloud Optimized Point Cloud, is it stores the data according to a cluster or to an oct tree. So it reorders that data and clusters it according to that oct tree. And then it provides that index as more metadata on the file. That does a couple of important things for you. One is applications that don't know anything about that can just read it like an LAZ file. It is just an LAZ file, right? So they can just read it, and get the points out of it. They don't need to be updated to consume the content. But if your application is enabled and speaks that metadata, it can take that file and query it again for a window or at a resolution. And it could do that over a network if it wanted to as well, right? So the ability to in the cloud, that's really important to be able to touch these large cloud object stores and incrementally read data, again, controlling your byte size. And so these two technologies are kind of both sides of the same coin, where it's we take an octree, order the data according to that octree, and then either store it, as they call it, exploded object store. As, I have S3 or Google Cloud Storage, or or we store them kind of clustered into an LAZ file, and we use them as that sort of transmit archival data format that we can federate and move around in bulk, which is typically how people are using data today.
Yeah, yeah. So maybe for our listeners who may not be as versed on some of the indexing jargon we're using, when we say quadtree, octree, what would be the short and sweet takeaway for someone who's not in this space on what that is?
So Octree is, just think of Minecraft. If you're a Minecraft user or your
Love
kid's
it.
a Minecraft user, they can keep zooming in, keep zooming in, keep zooming in, right? Ultimately, that's what you want to do with the point clouds as well. You want to be able to represent that volume, that voxel in Minecraft speak, with a single point, and you do that all the way until you're done with all of the points. So some of these could be very, very deep trees, but you don't need to read all of that data to be able to characterize the space. And so that becomes really important to be able to say something about these really large volumes of data without having to do lots and lots of compute work.
Right, right. So for the average user, they don't need to think about, I need to load everything all at once. We've got these indices that could help me load what I need at the right time and not
And
overburden
like
systems. Yeah.
kind of bringing it to forestry, like one of the top areas where I've seen that really happen in forestry is, people set up terrestrial scanners in forestry environments, or maybe they're flying drone captures in forestry environments, and they're capturing, tens, 20s, hundreds, 500 points per square meter, right? You can capture just humongous volumes of content. You don't need all of those points to be able to characterize the space. And so that octree allows you to filter that data and query it or access it to a specified resolution. Just, maybe I'll want to say 2 points per square meter, and maybe that's not enough for forestry. I don't know, but being able to control that, again, is very important for software applications to manage their computational complexity.
Yeah, yeah, no, for sure. And it's great. It's almost like, Howard, you're leading me down the question path, giving me the segues. But when we think about forestry, for our digital foresters that listen, there are other software that you're involved with more of a forestry flavor, is there not? And SilviMetric, I believe, is what it's called. So maybe walk our listeners, because now maybe some folks are sitting up going like, oh, okay, now I get where these guys are going, right? They're setting the stage on the technology, the nerdy stuff, and then hey, maybe there's some tools that I have not even heard about that I can actually leverage from Howard and his team and the open source community to do different things. But what is SilviMetric? How did it come to be? Where there's a sponsor? What was the thesis behind it, and where is it today?
So SilviMetric comes from collaboration with the U.S. Forest Service. So Bob McGoy from the U.S. Forest Service was working with us. So he had seen, kind of taken a small step back. So we managed this public data set. And so the public data set for the USGS is, it's a point cloud data set. It's like 3,000 different collects now at this point, and some 70 trillion points. It's like 370 terabytes in a
Wow.
AWS cloud bucket. And anybody can access it. It's open, it's zero cost access. You can go read it with your software over the network, right? And so being able to, again, I know where I'm at. I'm in Iowa City, and I want to read read the point cloud for downtown Iowa City and only process that. And so, and you can do that sort of thing with this public data set. And so then that sort of drove the conversation. Well, okay, we can do that for all of these areas in the US. How does that change how we would manage data for forestry modeling? And so for forestry modeling, working with Bob, and so Bob is the leader, of course, of the Fusion software, right? So it should be hopefully well known in this community.
Yep.
And Fusion, the data management story of Fusion is you're on your own, and and um, and so the consequence of that is you take all this awesome capability in Fusion, but then you burdened yourself with this data management challenge, which is, okay, I create tons and tons of these essentially raster layers that represent various metrics that come out of the Fusion software. Most of them I don't use. I might use some of them depending on whatever my modeling scenario might be, but I might need them, so I better keep it around. So then you end up sort of just stacking up all of this stuff. And then you have consequential choices you're making that you don't quite realize. Well, what's my origin and where I started from? And what's the coordinate system of all of this stuff? And then, okay, I modeled one or I extracted metrics from one forest, and then I have another one. They don't quite line up. How do I put them together and be able to do an analysis, whether it's two different forests that are next to each other, or maybe it's the same forest over time? And so we get to SilviMetric because we're like, well, if we reframe the data management challenge of all of those metrics to what if I just stuffed all that stuff into some cloud data store thing and it managed all of that. It did that data management junk for me. And I focused on processing point cloud data incrementally, being able to manage and construct all of the metrics that I would want, whether they're compatible with Fusion or they're my own metrics for whatever I want to extract. And then have that perform well too, right? Still needs to perform well. And so that's how we get to SilviMetric. So SilviMetric, um, the idea is you store everything as a frame. Maybe some of your listeners have heard of something called ZAR, ZARR, which would be a multi-dimensional data store, a cloud storage approach for multi-dimensional data store. There's another technology out there called TileDB, which grew up in the genomic space, which is what SilviMetric actually uses, but it's a very similar sort of concept, bizarre. And it's essentially just a giant hypercube that you can store raster array content in. And so using those Octree things that we were talking about before with the cloud optimized point cloud or Entwine point tile being supporting incrementally reading that data, we read those content and compute our metrics for whichever areas we want, and then store that back into this cloud object store thing. And then once that process is done, that data analysis, that forest modeler, whoever it might be, can just connect to that resource and can answer their questions without having tens of thousands of raster files named underscore final underscore whatever, right? So reframing that data management challenge to be based on some of these technologies where again these other domains like the genomics domain or the weather domain have had this problem for a while, so being able to leverage some of these tools I also think is a really important part of it. So that software SilviMetric is just been released. We just got a release out last week with some new capability, um, and starting to build out some of these larger data sets. And again, it's all open source. So if you're interested, just go search for it and give it a spin, start participating.
Yeah, yeah, cool. So thinking of that, what I heard was that you could potentially, not potentially, you would use SilviMetric to maybe generate some of the traditional lidar metrics that they might use, like the 90th percentile raster or whatever. So maybe not quite a full fusion replacement, but maybe better data management so that you can then use it in the pipelines for other things. Is that a good way to think about it from the
Yeah,
digital
I think
forester?
we have almost all of the fusion metrics, grid metrics as they were defined by Bob. So there might be a few that are a little bit different, but we've been working with Bob to make sure that it's possible to do that transition without having to change the analysis side of it, right? Like that's already hard enough, right? Like you're making me change my data management. Now I don't want to change my analysis too. Um, the other kind of important part of the story relative to Fusion is Fusion's a command line C++ tool. Wiring that back up to Python, where you might be doing your data analysis, or maybe you have some data scientist who wants to do graphics and analytics based on things. They're in Python land. That's where they're more naturally comfortable. SilviMetric brings that to them, right? So they are able to connect to the using TileDB. They're able to connect to this directly and query for again for a window or a resolution. And they're also through the metadata that's available in the data structure, see exactly how that metric was defined in the Python that defined it. And so that has a lot of benefit for people doing like custom metrics or things where they might be adding their own. And so, I think that's something that doesn't exist in the space. And so, we're excited to kind of put that together.
Yeah, well, hopefully some of our listeners who are maybe paying for other COTS tools will hear this and go, "Oh, maybe there's an opportunity here to work with you and the team there at Hobu to kind of bring flush this out some more." So you
Again,
mentioned 70 trillion points and stuff like this software that we talked to. Are there any constraints, or are they so well software architected or architected in general that they are high performing and don't really have any constraints in terms of volume of data? Is that one way to think about it? That these are just well software architected pieces of code that scale with whatever needs people may have?
um, we've worked very hard to make this stuff work well. And so the, we've failed a lot.
You
We'll
learned
say
a
it that
lot.
way. Yes, we've learned through failure a lot. Again, like the hammer you have is divide and conquer, and so being able to efficiently divide that data and process it so that you can throw as much computing as you have available on your machine or in your cloud instance or whatever it might be. Like that's ultimately the name of the game.
Right.
And so are both the data organization tools, so that's Entwine Point Tile or Cloud Optimized Point Cloud, and then the algorithm tools, so that would be things like Oodle, LasPy, LasTools. They all speak Cloud Optimized Point Cloud. And then in the case of SilviMetric, it's okay, can we bring some of that stuff to Python in the data science and more the analytics type space? Again, the biggest advantage of all of these things is they're open source, meaning if you start developing or building with them, you own the technology that you've built. And so, one of the things that we found working with some of the forestry companies is they're large. Lots of them are quite large. They're not afraid to take on capital expenditure to build systems to manage their stuff, right? And so, being able to own that capability and use it over a very, very long time is important to some of them. And so, these tools provide opportunity to do that. And it also provides opportunity for them to jump in the space and participate if they want, both as contributors and as sponsorship, of course.
Right, right. So I'll role play a digital forester, but Howard, it's like my stuff's not in the cloud, and you talk about cloud optimized point cloud. Is cloud, does it really need to be in AWS, Azure, Google Cloud, or is it really the idea it's not it can exist elsewhere no matter what that is?
So, yeah. So if you hear the phrase cloud optimized blah, all that means is the ability to access that content incrementally. So if you think of it like your Netflix stream, when you're watching TV on your your Netflix stream isn't reading the entire 20 gigabyte movie file, right? And when you hit the seek button, it figures out, well, which bytes do I need to go ask that server for to be able to satisfy your request for seeking ahead, 5 seconds or 50 seconds or 5 minutes. So that's exactly what's happening with cloud optimized point cloud is there's an index at the file that says, here's how all this data is arranged so that an application that's smart enough can say, well, I want to read for this window. I know exactly where I need to go ask for data.
Yeah.
So if you see cloud native geospatial or analysis ready data or cloud optimized, these are all kind of synonyms for that sort of concept.
Right, right. Love it. Love the examples. It just tells me you've been asked those questions way too many times and have prepared these great responses to that. So in terms of you've walked us through the different tooling that's available, but we're at the point where I gotta see this stuff, Howard. So it's like, yeah, I got great open source technology you've contributed. I can manage it. I can build pipelines. I can generate these things to drive analysis. But ultimately, the visual is the sexy part. I need to see my trees. I need to see my point clouds, my outputs. So what do we have on that front to empower users that want to continue down this journey and story?
So that's where we get to proprietary software, at least for my company. So I've been active. We've been active in that space as well. So at least for pure point cloud, of course, there's a number of visualization tools available. Of course, they all tend to start with one seminal open source point cloud project called Poetry. And so, we've worked with Marcus Schutz for quite a while, both in developing Poetry itself and developing kind of the data organization capability that was needed to make Poetry happen. So Entwine Point Tile and Cloud Optimized Point Cloud and the Poetry format all share the exact same model for their octree, right? And so that's where that stuff originates. And so we've been active in Poetry, and that's open source that you can go grab and build your own systems with. It's kind of a harsh environment for developing very complex GUI systems in the browser, though. Again, this is all browser-based technology, right? Being able to view stuff in Chrome or whatever. Lately, we've been working more towards Cesium, and Cesium and Cesium JS specifically provide is a very capable JavaScript framework for building very complex 3D applications in a browser. Has a data model. It's called 3D tiles that is quite capable and models things besides point cloud. So it models meshes, it models rasters, and vector 2D vector type things, and of course point clouds as well. We've been bringing our formats though that we've been using, which are more these level two formats, right? They're not formats that are designed just for visualization. They're not formats that are designed just for a particular processing approach. And bringing those to Cesium.js through a software library and framework we call Eptium. And Eptium is kind of a point cloud application for Cesium. So things like filtering those point cloud, maybe by classification value or adjusting their coloring or potentially adding multiple together and looking at them over time, things like that. So providing that capability there via that browser application. That browser application is available online, and I'll at usgs.entwine.io, some links that can get added to the notes here. But then you can use that to kind of browse this 70 trillion point cloud, and look around at it. Again, that application knows how to do the Netflix thing, right? So it knows where it's located. It knows how to ask for the bytes it needs to satisfy your view request and do that efficiently without over selecting content.
Cool, cool, very cool. And so thinking of that of you've touched on it, at the start you're like, oh, when we were messaging, it's like, oh, not as much forestry. But when you think about maybe the folks that you work with, is there a split, like a clear split, maybe more land use type applications you see, maybe more agriculture, maybe is there a certain segment where maybe the adoption of some of these open source technologies are you're seeing more prevalent than other spaces, or is it pretty much a complete mix. It doesn't matter. It's just a smorgasbord of players across different verticals or sectors that use this technology.
Um, I think so. The a big area of adoption, of course, has been in governments, where these governments are essentially providing, like, NRCan, for example, has their lidar program that they're pulling data together. They provide all their content available online in an AWS bucket via S3, right? So you can stream that content into your LASPI application or your browser for visualization with our tools, or into directly to Poodle if you were doing some command line thing. And so governments are certainly big users of this technology as in that role of archive and transmission. They're definitely using the technology to prepare that content. So the open source tools to filter and manage. Maybe they're using it to do quality control and their data production pipelines as well, where it's kind of up at the front of their this, where they're doing QC and detection, error detection, those kinds of things. I know it's heavily used for that. And then in the private space as well, we get a lot of contact about people using Poodle for specific things. I mean, it's the way I say phrase it to people is Poodle is a box of Lego, right? It's a bunch of blocks that you can snap together and make your own spaceship, but it isn't a spaceship, right? We don't necessarily provide recipes, and except for some very common ones. And so people can do very complex, fabulous things with it. And we see this all the time where we didn't know it was possible, which is a good indication that it's a generally useful general tool. But so we'll see it get used in commercial spaces for those kinds of things, especially when it comes to things like coming up with complex filtering algorithms for various scenarios. Maybe you had a sensor that is a static sensor that's pointed at a scene that's changing all the time. Maybe it's a mining type scenario, and you want to clip the data to a particular window and run these particular filters always at the same time. That sort of automated scenario is, a perfect fit for something like Poodle, where you essentially every time a scan comes in, you just fire this process that does this sort of fixed thing.
Yeah,
And then finally, we see it a lot in the data delivery and data librarian scenarios, right?
makes
Like the
sense.
NRCan thing or the USGS thing, where it's like, hey, we're going to lay out hundreds of terabytes of content. How do we store that in a way that our users don't have to download hundreds of terabytes of content to the data be useful for them?
Yeah, no, makes sense. And for our listeners, NRCan is Natural Resources Canada and USGS, U.S. Geological Survey. So certainly, yeah, maybe there's some other state entities that are listening to this that could actually benefit from
There's
other
a number
tools
of
that have
a
been
number
fixed.
of them in Europe too. Certainly are doing the cloud optimized point cloud thing,
Yeah.
usually in a bucket, or maybe they're hosting it on their own HTTP server. But
Yeah, yeah, yeah,
that
for
allows.
sure. For sure. So thinking part of the Digital Forester podcast, we always like to get experts like yourselves to kind of maybe vision cast into the future. So maybe what's exciting you maybe 3 years out and 10 years out, working in this space, obviously for a lot of time, you've seen a lot of technology come and go. You've seen some technology with a lot of staying power like GDAL and whatnot. But if we look to the future, what are some of those things that you're keeping your eye on, or maybe thinking about in a different way to whether incorporate in terms of the technology you're developing, or maybe is there something that you're hoping will mature, evolve further because it'll solve some pain points you've seen in your career? But what are you looking forward to into the future from a tech lens?
Okay, I have this kind of sort of patois where I say people hate point clouds, um, and it's kind of been true over the career here with the point cloud stuff. Is they want to get to point something other than point clouds all the time, right? Because they're hard to visualize. It looks like the Matrix. They're hard to process against because you have so much data. They're hard to filter. They're hard to explain to somebody. Um, I think what's going to happen though is we're going to keep having more and more point clouds, and they're going to get more and more complex. So one of the areas, so we have our community, at least the lidar community, is very used to an active scanner where we have a laser firing and we're capturing data. But if you've been tracking the photogrammetry space, this Gaussian splat stuff, where we're taking AI and essentially creating a modeled point cloud of a photographic scene.
Maybe
Um,
explain that for our folks. Is guaranteed 99% of them will be like, wait, what? Gaussian splat? Is that like a type of ice cream or something? How would you describe it at the general for the generals to absorb?
so the photogrammetry problem where we're going to take a bunch of images from a bunch of different perspectives over a scene and try to calculate what points in those pixels actually are at the same locations, right? So it tends to be very expensive computationally to do it. Gaussian splat takes that a step further and says we're going to try to predictively estimate where the position of those pixels might be in a scene, given enough pixels that we can do that. And so you can create much more detailed estimations of position using Gaussian splats. You still have to do coincidence matching with your images, but then after that, you get to essentially extract a lot more kind of predictive position capability out of the scene. So if you have a really high density movie of an area, or maybe you have lots and lots of capture of pixels, throwing it into the jumble box and doing a bunch of computing to it allows you to extract a very photorealistic estimate of that 3D estimate of that scene. But that 3D estimate is a point cloud, and it's a point cloud where those points are probabilistic estimates of position. And so being able to do stuff with those takes that computational challenge another step further. Now we have to say, well, given where I'm looking, what is my estimate of what I could see in a particular spot? And so I don't think we're going to get away from point clouds, unfortunately. But hopefully some of these tools will allow us to process them and ask questions of them more effectively. Bringing that Gaussian splat stuff to the forestry sort of domain, maybe you have like a fixed active scanner capture of your forest at a point in time, and then you want to go backfill that with another estimate of position. You might use, there's tons of different sensors available to you to do that, whether it's photogrammetry or radar or what have you. Um, you know, maybe we have like tons of little drones going and flying around in the forest and capturing essentially all of this pixel product, right? It's just pictures, and dumping all of that into the jumble box and using that fixed base that we captured with this really expensive to acquire lidar, and then backfilling it with some of these other technologies like a big Gaussian splat field.
Hmm,
So
interesting.
that would be an area I see potentially a lot more. It's much more cost effective, right? Like lidars
Yep.
and airplanes, and even you put them on a drone, like they're really expensive. You're burning lots of battery to hover them around because they're quite heavy and so on. Whereas the technology is so much cheaper. The compute side of that is maybe more expensive, but it's a lot easier. So
Right.
um, I see applications like that maybe starting to become more available, but they're still going to require lots of technology, um, open source or otherwise, lots of compute, and then algorithms that answer and allow people to answer questions effectively and conveniently. Those are a very important part of it.
Yeah, yeah, absolutely. No, thanks for sharing those thoughts. And so thinking of that, I'm just watching our time. I was like, do I want to ask this question? Because I want to be respectful of your time together. And then I was like, no, I know I got to ask it. Everyone's excited about AI. So I really like that Gaussian splat, like something I haven't heard as much in terms of things going forward or new paths forward. But the other one everyone talks about is AI. When you think about AI, yes, and the work you're doing, is there somewhere there for it to help do points better since we're never going to get away from that? Or is that an area where the generative AI just doesn't really work quite as well because your space is more algorithms versus generative things? What are your thoughts on that with AI in your space? Do you think it, aside from leveling up software engineers as having a co-pilot to help them go quicker, do you see anything currently in the AI space that would really move the needle for the work you do?
In the point cloud space, I mean, there are some tools that we've played with, like there's Segment Anything, Segment Point Cloud, some of these sort of segmentation type tools. They're very computationally intensive. Um, if you're having to do a bunch of handwork afterwards, then it's hard to know how much value you're getting on them. Maybe they're good as a first pass, and then once you get to that segmented point cloud, you're kind of done anyway, and your algorithm is sort of deterministic and extractive. Um, I, I've another challenge with it is at least in space, the AI in space problem is, you have not just one dimension, it's like four or five or six more dimensions to figure out where you're located and provide context to it. And it's just very difficult for LLM type technologies to take advantage of that. But like you say, we're definitely seeing the developer level at the kind of user level, being able to take those tools, summarize and educate themselves about what might be going on with the data or how approaches that they might take to get the kinds of answers they want out of that data, or a thought of way, right? Like if you can come up with if you can formulate the question, maybe you can answer it, at least get on the road to answering a lot more effectively than you might otherwise have been. I mean, the sort of AI magic wand for point clouds is certainly not there yet, and probably won't be for a while, but there are definitely tools and open source and otherwise to take advantage of and do some of that thing.
Right, right, for sure. No, thanks for that. And so as we look to wind down, Howard, uh, I suspect this pod's maybe a little bit more techy than past ones, which is okay, absolutely. But I'm also going to anticipate some folks that are thinking, "Wow, there's a lot here that's really really good. I need to learn more because I can probably benefit from what Howard shared with us." But I feel overwhelmed. What's your advice for them to get going to learn about some of these open source software that you've talked about? Are there resources online that maybe Hobu Inc has or whatnot? But what's the best way for someone to get going to really understand what is available today in the world that you live in?
Have a problem, I think, has been the most important one. Like it's just very frustrating to learn about a bunch of general tools, and you're like, how do you snap them together? So, the problem I have and have been exploring a lot is so all of this lidar data that's now available is exploring tons of archaeology, or is exposing tons of archaeology that people knew was under the canopy but couldn't quite see. And so, a fun one that I've been participating with, there's a Facebook group. I'm old, so I can be on Facebook. And it's essentially LiDAR and archaeology. And so, all of the LiDAR that's been made available in Europe, is available as essentially a ground only hill shade, or all of the LiDAR that's available in the US and Canada is available as point clouds. And you can use those data to go ask questions about areas like, how do I filter this point cloud so I only look at the ground? Or how do I filter this point cloud data to extract it from a particular view? So again, having that problem, I think, is important. And then as far as you know, s- tools to go seek out and search, so you can write Poodle pipelines with Chat GPT. It worked quite well, actually. So a lot of that is a function of us having documentation that provides examples and provides information for the LLM to be able to kind of synthetically snap stuff together. And same with GDAL and these other tools as well. And so that's a good place to start, actually.
Love it.
Um,
Love it. Love it. Use the AI to help you with the large language models and LLMs there to get going. Very cool. And of course, folks can reach out to you and Hobu Inc. and the Hobu team to help out on whether new projects or maybe to accelerate the development and other aspects of the open source solutions. So, thinking of that, I really want to thank you for your time. For folks who want to get a hold of you, Howard, what's the best way for them to reach you? LinkedIn, social media, what
yep,
email,
yep.
website? What's
LinkedIn,
the best
all of
way?
those things are fine. You'll find me on LinkedIn or
You're a
GitHub.
modern guy, so even though you use Facebook, we won't hold it against you. I use Facebook too, and my kids say like, "Oh, like only the old people use Facebook." I'm like, "Well, yeah, I'm okay with that. So anyhow, we're dating ourselves there. So there you go. For folks who want to follow up with Howard here at Hobu Inc., feel free to reach out on LinkedIn, webpage, I believe it's hobu.co,
Oh,
not com, .co, and just ping Howard and he'll be happy to help you out. So thanks very much for joining, sharing the work that you've been doing. Very, very cool. I know I'm going to go dig in and get my nerd on and actually play around with some of this technology because truthfully, some of them are new to me, and I'm curious to see what they can actually do. So definitely want you to thank you for carving out some time, and I'm looking forward to seeing what you and the Hobu team do in the future.
great. Thank you much for the opportunity, Kevin.
Awesome, good stuff. We'll talk soon.